Here we go. I'm going to try to finish the rest of this packet. I'm going to use some keywords here. You can go back to the slides. That did not work for me the first time, but here we go. We're going to try with just my voice. I'm not going to go back to the slides, and a highlighter and a pen, and then you're going to have all the right answers. Hopefully we'll have no distractions as I do this. Number 1 on page 2 of the packet. It again has those little hints with the slides on it. It says the diffusion of water through a cell membrane. The key word is water. Anytime you're talking about water, that is going to go with H2 osmosis. So letter E is the answer. Number 2, the movement of substances through the cell membrane with the use of ATP. Anytime you see the word ATP, you should be thinking about the term energy. When you hear energy, energy is like activity. Activity is going to be letter B, active transport. Number 3, a protein that is used to help substances enter or exit the cell membrane. So proteins, well, wow, okay. I'm thinking that it's choice A, protein channels, okay? That's going to be in slide 2, I believe. So let's put that down for choice A right there for number 3. When a cell moves liquids into the cell by utilizing energy, but it also has the term liquids. So liquids is kind of important. And when you talk about liquids, that's called pinocytosis. Okay. Please. Number 5, when the molecules of one substances are spread evenly throughout another substance to become balanced. Ooh, balanced, that's an important keyword. It also says that it's slide 11. I'm thinking that anytime you use the word balanced, it's going to be choice H. Equilibrium kind of sounds when you say balanced, equal. Number 6, a membrane folds and the contents released into the cell. When you're talking about a folding membrane, well, let's say we don't know that one. Let's just say, okay? And you could always look it up on slide 20, and then it would have the term with it. But if you don't know something, here's a good test-taking strategy. A test-taking strategy would say, you know what? I'm going to skip that one because I'm not sure of the answer, and I'm going to come back to it. Maybe I'll get some other answers, or maybe I'll start narrowing down my choices. So number 7 says the cell membrane forms around a paramecium from an amoeba to its, from an amoeba's nutrients. When we're talking about forming around it, so forming around it is kind of like a pinching off. That's phagocytosis. That's letter F. Slide 22, when molecules move from areas of high to areas of low. This is our term that we're going to be learning about, areas of high to low. That's cell transport. That is passive transport. I don't see that as a choice. But if I see, do I see passive transport as a choice? Let's see. Let me go back up to the top. No, diffusion is left though. So that's moving from high to low. So I have D. I used F. Oh my goodness. Contents are released into the cell. I have this one left. C, into and entering. Kind of sounds like endo, entering endo. Might be a way to remember it. Flipping the page to the 3rd page in the packet, I did say use your Ed puzzle. There was 2 Ed puzzles that you needed to know about. The Ed puzzle gave hints. It also gave video and questions and answers. So if you use the Ed puzzle to help you with this, that's always a good way of using your resources. So if we take a look, we're going to define each one as hypo, hyper, isotonic. So those are your directions. Now there should be one that should be automatically very easy, and that's this balanced one, where the arrows are both going in and out, and I could automatically say that that one is isotonic. Then I've got these two other ones, and I have to start thinking, maybe I'll start thinking of practical applications. Well, this one, the arrows are going out. So this cell is going to shrink. It's going to get smaller. Whereas this cell, the arrows are pointing in, this cell is going to possibly burst. Now, anytime you see these arrows are showing motion. So that means that this is moving, this water is moving out of it. Water moves out. This one, water is moving into cell. So now I need to compare it to the outside environment. The outside environment, it tells you, is very salty. This one is not salty, it's pure. So when I look at this solution, very salty is going to be hypertonic. Not very is going to be hypotonic. The next page, I know I'm jumping around a little bit. The next page actually shows that. I'm sorry, it's the page after that. Okay, so if I take a look at this page, page 5, I would say, hey, look at this. This is 5% water on the outside in this solution, and this is 95% water in the inside of the cell. So when I'm looking at this, the water is going to move from low water, from high water, not 95%, to low water, 5%. As this happens, the water moves from inside the cell to outside the cell. That means it's moving from inside of that circle to outside into the solution. When that happens, the water will flow, look at the arrows, out of the cell, and the cell will shrink. Now, if you take a look, this would be a very salty solution. Why? Because it's 95%. And that's why in the directions here, it said use arrows to show. This one over here, it's saying 95% water inside of the cell. I would definitely label those. And then the outside is, it's the same, 95%. So they're equal. That's equilibrium. Those arrows are going to be going back and forth. The water is going to be moving in and out. So that's going to be going in both directions. And the cell will stay the same because it's both directions. Number 3, kind of a tricky one again. Number 1 is tricky. Number 3 is tricky. But you have to try to look at those numbers and always label inside the cell. And this is the outside solution. Okay? So I look at just my water. My water's 5 on the inside, 95 on the outside. So it's 5 on the inside and 95 on the outside. Osmosis says it's the movement of area of high to an area of low. So let's see. High to low. So the cell will flow out. The water will flow into, look at the arrow, into the cell. and the cell will burst. Okay. So the swelling happens when it's a hypotonic. It doesn't change the shape. That's going to be isotonic. Causes osmosis. Everything is osmosis. And then shrinking is hypertonic. Okay. Looking at page 4 in your packet, you have to use the word bank to answer about these 3. So the first one, you're moving from high to low. That one, I have diffusion, active transport, osmosis. Let me just put a little definition next to each one. Diffusion is high to low. Active is low to high. But this one, active, has that term active, which means it's going to have ATP or energy. Osmosis, H2, osmosis. So that's always going to involve water. And then equilibrium is balanced. Okay. So the term I'm going to use for diffusion is anytime they're moving high to low. Well, this one's moving high to low. So this one, the answer is going to be diffusion. Number 2, oh, I see H2 osmosis is the answer. Number 3, 25 to 5, that's going to be moving high to low, diffusion. Number 4, H2 osmosis. Number 5, low to high. Uh-oh, it doesn't say anything about energy, but it is moving from low to high. And that's going to be active. Whoops. Transport. And then the last one I see is H2 osmosis. There's also something special about number 6. If you look at the numbers, it's 10 to 10. So that's equilibrium as well. Is there any other ones that are like that? 2 to 8, high to low, 8 to 2. Nope, so this is the only other one that has the equilibrium. And if you put osmosis, that's a double right answer for page 4 in your packet. Page 5, osmosis, here we go. It says osmosis is diffusion of water from an area of high salts to an area of low salts. Only water moves in osmosis, and the diagrams below show the concentrations of water and salt inside the cell and the concentration of water and salt surrounding the cell. Complete the sentences below by comparing the concentrations of water inside the cell, which is inside the circles, and the concentrations outside the cell. So draw an arrow to show the direction of water traveling. So if you take a look, that this is going to be an area where this is going to be shrinking. A shrinking cell means that it's very, very salty on the outside. That's going to be a hypertonic solution. This one is going to be a equilibrium. That's going to be an isotonic solution on the outside. And then this one is going to be a swelling of the cell, and that's going to be considered a hypotonic solution. Okay. Just to reiterate those solutions. Moving on to page 6. This diagram is hint water. Water moving is osmosis. The diagram describes, I gave the hint of farts spreading out. And this is going to be diffusion. These are your terms you need to know. Number 6, I think I actually gave you a little word bank without putting it in a box, but you have these 3 terms. This is low to high. Automatically, I would do this as active transport. This one, oh no, I'm getting engulfed. Oh no. This would be endocytosis because it's entering or being engulfed. And I'm not sure if maybe I should put arrows in there, but that's showing that it's leaving, and that's exocytosis. No. Always cross out as a good test-taking strategy. Number 7, these are some Regent style questions. So these are things that you may see on your Regents exam that you're going to be taking for next year. You may have also seen this when we were doing our eggs, our egg cell. So looking at this, in the diagram below, draw 5 starch and 12 glucose molecules to show where they would be located after 15 minutes. So if you remember from the egg cell, only the small stuff crosses the membranes. So the small is going to be your glucoses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not enough. They want 12. 11, 12, and you could color those in because those are dark, right? Because the key tells you they're dark in color. And then my starches will not. Okay, so they are going to stay 1, 2, 3, 4, 5 of them. They are going to stay. They cannot cross the membrane. Only small molecules cross membrane, cross the selective membrane. That's number 7. Flipping the page, page 8. Again, these are all Regent style questions. The diagram below represents 2 processes. A characteristic represented by X is common to both of these. Well, what happens with diffusion and active transport? Both of the processes, the 2 processes, well, do they both require ATP? No, that's only for active transport. Do they both require enzymes? Maybe. Do they both use oxygen? Not always, so that doesn't make any sense. Do they both move molecules? Wait a second. That's what we're talking about, is moving those molecules. This is the title of this unit is called cell transport. That word transport means movement. Movement of molecules. Choice 4 is correct. Number 9, which activity can occur without the use of energy? So that means without. That means no energy required. So no energy. Not necessary. Contraction of muscles? Well, muscles require energy. Protein synthesis in a cell? Maybe. Active transport? Definitely not. That requires energy. Movement of water? Wait a second. I saw that in the egg experiment. Choice 4 is correct. Please flip the page. I'm going to cross off page 10. And I'm going to look at this last one. And my pen is running out. It says in the diagram below, the dark dots indicate the small molecules. Small molecules move across. These molecules are moving out of the cell as indicated by the arrows. The number of dots inside and out of the cell of 2 cells represent the relative concentration of the molecules inside and outside of the cells. So if you take a look, ATP is being used to move which of these? Well, this one has 4. Whoops. Okay. This one has 4. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9. On the outside, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this one has 1, 2, 3, 4, 5. So this one is moving from an area of low to high. This one is moving from an area of high to low. So B is high to low. Cell A is low to high. So when you're moving from low to high, that's going to be the term diffusion.